Hey everyone, Mr. Skelton here. We are back at it. We are starting lesson 6 in Unit 2, and today we're going to be transitioning to three-dimensional systems. You'll notice with the example problems you'll have x, y, and z, so we have three variables and three unknowns. And today really what we're going to focus in on is solving the systems by elimination, which you already know how to do. So a lot of this you'll see is review. Now, the whole goal I'm just going to jump to the first problem here. The whole goal of solving this system is simply this. We want to basically take a 3 by 3 system, which is what we have here, and we want to create or make that into a 2 by system. And when we get that into a 2 by 2, that is what we've been doing since Algebra 1 days, and then we transition that into basically a one equation or 1 by 1, which you have, and then once you find your solution, you kind of go backwards and plug everything in until you find the other two variables that you want. But the big thing here, the big goal for you is to always understand that when you have a 3 by 3, your first goal is to make that into a 2 by 2. And the big question is, okay, how do you do that? What you want to do is you want to look at the variables. So I have x here, I have y here, and I have z here, and I have them lined up for you. And you want to see which variable lends itself to be eliminated twice. So the answer to this question of how is you want to eliminate the same variable twice. Okay? You want to get rid of the same variable twice. So you want to have a focus. So if I look at this right here, I usually label the equations. So I have equation 1, 2, and 3. So 2x minus y plus z equals 4 is 1, and so on and so forth. And I just off to the side, or wherever I have my ability to show my work, I'm going to look at my z's, and I have a plus z and a minus z. Now again, you and I may differ in how we actually solve systems, either by adding the two equations together or subtracting them, but I'm just going to take equation 1 and I'm going to add it to equation 2. And so it would look something like this. And I'll rewrite it for this first example just to give you the detail. But for the most part on this one I probably would, just because it's pretty self-explanatory. But there's equation 1 and equation 2. Okay, that's what I'm going to do, and I'm going to add these two together. So my z's would cross out, 2x and x would be 3x, negative y and 3y would give me 2y, and 4 and 11 would give me 15. Now, that doesn't really solve or give you something, but again, remember, you're transitioning from a 3 by 3 to a 2 by 2, so now look what's happened. We've gotten rid of the z, and now we just have an equation that would look very similar to what we've done in the past. Now, our goal is to eliminate the same variable twice. So I'm going to go back to my equations, and I need to pick a different combination. Now I could go equation 1 and equation 3. I could go equation 3 with equation 2. I just can't repeat equations 1 and 2, but I can use any combination to eliminate that variable. So I'm going to use 1 and 3. If you look at 1 and 3, when I look at that, I see a positive z and a negative z. So again, I'll write it out so that you can see it for this first example. And I'm going to add those two together. I know some of you will subtract those equations together, but I like to add my variables together. So my z's again are gone. That gives me 6x. Now look what happens here. This is a nice little bonus. This normally doesn't happen. But I have a negative y and a positive y, so those also cancel out, which makes my life really nice here. And I end up getting 6x equals 18, because 4 plus 4, 14 is 18. Well, normally what would happen here, and you'll see this in another example, is I would have 6x, plus or minus some y variable equaling 18, and then I would take these two equations and solve them like a 2 by 2, which is what you've done in the past. In fact, you did that in two or three lessons ago. But because this worked out so nice and I had two variables end up eliminating themselves out, I can just divide both sides by 6 and I get x equals 3. Now what do I want to do with that? Once you get a variable, you just want to start working backwards. So for example, when I added equations 1 and 2 together, I got this equation. Well, I can plug that 3 in right here. 3 times x, which is now 3 times 3, which is 9. So this becomes 9 plus 2y equaling 15. So I can minus 9 from both sides, and I get 2y equals 6. And then divide both sides by 2, so y should equal 3. Now I have x and y, and now I need to figure out what z is. And again, once you have your one equation, so x equals 3, that's considered an equation, you basically just work backwards. You plug it into the 2 by 2, which I did here, and then I'm going to plug those answers back into my 3 by 3 to get my x, y, and z. So I can pick any equation. I usually try to pick one with the smallest numbers in it. So I'll use equation 1. So that would be 2, and now I have a 3 in for x, minus y, so minus my y value, which is 3. And then you'll notice I always use parentheses when I do substitution, because if I have a subtraction sign, I need to make sure I handle that appropriately. And then plus z equaling 4, so this becomes 6 minus 3 plus z equaling 4. 6 minus 3 is 3, plus z equals 4. Subtract the 3 from both sides, and I get z equals a 1. When you write your answer, you usually write this in alphabetical order if you're going to make it a point, which we haven't really got into graphing three-dimensional points yet, but we'll get there. But we would go x, y, z, so it'd be 3, 3, 1 would be a way to write your answer. Or you could go the traditional way and just stack them if you would like, or put them kind of in a line, however you want to do it. Either way will work for me. But we're going to get into naming points and graphing them. Okay, so let's take a look at the back. And the back is another question. So what I'd like you to do right now is just go ahead and hit pause, and I'd like you to try number 2 on your own. See if you can solve that system using elimination. And again, remember, the goal is to eliminate the same letter twice. You want to get rid of the same letter twice. Okay, so let's take a look at this. The one thing I always do is I always double check to make sure my variables are lined up, which they are. I got x's, I got my y's, and I got my z's. When I look at this equation here, my eyes go to the y's. This is equation 1, 2, and 3. And again, I always label my equations. You don't have to do that. I do it just to try to stay organized. And I'm going to try to focus on my y's here. The reason is because if I look at equations 1 and 2, my y's will be gone. And if I look at 1 and 3, my y's will be gone. So I'm going to start there. I'm going to, off to the side, I'm just going to add my equation 1 plus equation 2. Now, I'm going to do this without showing every single step. So I'm just going to add 1 and 2 together because I see the plus y and the negative y, and I know those will cancel out. So I'm going to add my columns here for 1 and 2. 2x and 3x would make 5x. My y's would cancel. Negative z and 2z would just be a regular z. And then 5 and negative 1 would become 4. And then I'm going to go ahead, and I focused on 1 and 2, so now I'm going to go, okay, a positive x and a negative y. I'm going to focus on 1 and 3. Oops, 1, 3 and 1, doesn't matter, 1 and 3. And I'm going to add those together. So my x here, 2x and x is 3x. My y's, obviously, if I add those together, I get 0. Negative z and negative z would be a negative 2z. And I get 5 and 0, which makes 5. Now, this is not our answers, but this is our new 2 by 2 system. So I'm going to rewrite this so that it stacks nicely. And I probably could have done that just a step ago, but I didn't. So now I have something that looks like that. And these are the problems that are probably more common than the first one we did. So let's just hit pause for a second and just think about what we did. I had a 3 by 3. Remember, your goal is to eliminate the same letter twice. I eliminated y twice, here and here. My result gave me a 2 by 2 system, which is something that you're familiar with working with. And now you attack that like you would anything else. So when I look at this, I want to get rid of my z's. I'm going to times this top equation by 2, and I'm going to rewrite this. So that'll be 10x plus 2z equals 8, and the bottom's going to stay the same. And I'm going to add those two together, so those would cancel out, and I get 13x equals 13, and I get x equals 1. And then once I find that, I want to plug that back into any of the original ones that I had. So I'll use this one right here. So that'll be 3 times 1 minus 2z equals 5. So that's going to be 3 minus 2z equals 5. I'm going to minus 3 from both sides. And I'm going to get negative 2z equals 2. So z is going to be a negative 1. So I get z equals negative 1. And then I go back again to the very last. And I'm going to plug, I'll use the first equation. So 2 times x, which will now be 2 times 1 because x is 1, plus y. I don't know what y is. That's what I'm going to find. Minus, and again, I use substitution here. So here's a good example of why I use parentheses. The problem says minus z. Well, my z is negative, so when I go ahead and solve this, a minus minus becomes a plus, and that's going to give me 3 plus y equals 5, and then I'm going to get y equals 2. So my final answer is 1, x, y, and z, and that would be my solution to the system. Now, the nice thing about systems, and I didn't mention this on the first one, but we should always check to make sure that we have the right answer, and it takes really no time at all. You plug all three of these into all three equations just to make sure your left side equals the right side, so that you know that you didn't make a mistake. I'm not going to do that now because I want to keep the video rather short for you, but you can go ahead and do that on your own and make sure that you are getting the correct answer. Okay, so let's move on to the last one here. You may need a calculator for this, or your phone, and whatever you have on hand. But a real world situation here at McBeef's. All right, oh, McBeef's, gotta love McBeef's. At McBeef's, you can buy 2 orders of fries, 5 hamburgers, and 3 sodas for $24. Okay, we've done enough of these to figure out that you're going to be creating a system here, and I'm going to let F be fries, H be hamburgers, and and S be sodas. Those are going to be the variables that I'm going to be using. I can just figure that out in the first sentence. I kind of know, you've done enough problems to kind of know where this problem is going to be going. I'll keep reading. However, if you buy 4 orders of fries, 2 hamburgers, and a soda, it's 14. At the same time, 3 orders and 1 hamburger and 2 sodas cost 11. How much is each item? All right, so we got to find what the value of F, H, and S is for these sodas. So basically what you're going to do in this problem is translate each sentence into an equation. All right, at McBeef's you can buy 2 orders of fries, so 2F plus 5 hamburgers plus 3 sodas is $24. And I have 4 orders of fries for the second equation. This is the second sentence. 4 orders of fries plus 2 hamburgers and 1 soda. It will be $14. And at the same time, you have 3 orders of fries plus 1 hamburger. You can put 1 H, you don't have to. You can just put H. 3 orders of fries, 1 hamburger, and 2 sodas is $11.50. How much of each item will there be? So here is your system. This will be equation 1, this will be 2, and this will be your third. Now if you look at this, you have no negatives, okay? And so we have to make sure we're careful with eliminating the same variable twice. Now when you look at these numbers, if you look at your S's, your H's, and your F's, you have to decide, you know, what route you want to go down, what letter you want to try to eliminate. So it's really your choice. You know, I mean, you can try to work with smaller numbers. That's usually a good thing, and something that's got small multiples. I'm going to try to get rid of my S's. When I look at my S's here, I see equation 3 and equation 2. I'm going to multiply this first equation by a negative. So I'll do this I'll kind of box this up so it doesn't get in the way. But I'm going to times equation 2, so I'm going to go 2 and 3 here. And I'm going to take and multiply by a negative 2 on equation 2. So it'll be negative 8F minus 4H minus 2S equals a negative 28, because I multiplied everything by negative 2. And then on the bottom one's just going to stay the same. Okay, and my S's will cancel out here. I'll get negative 5F, and that's a negative 3H. And then I need to get my calculator here. And I have, let's see, basically 28 minus 1150. That's going to give me 1650, but that will be negative, so negative 1650. Okay, I don't know, my writing's a little sloppy, but this is good. This is going to be one of my new systems of one of my equations into my system of equations. Now I went with 2 and 3. So now I need to eliminate my S's. So again, I'm going to look at it 2 and 1. And when I look at 2 and 1, I'm going to multiply now equation 2 by a negative 3. And it's okay that if I use a different multiplier, I'm going to multiply by negative 3 because I see the positive 3 there. So I'm going to write this out. So 2F plus 5H plus 3S is equal to 24. That's the first equation. And then the second equation, again, I'm multiplying everything by negative 3. So that's going to be negative 12f. It's going to be a negative 6h and a negative 3s. And 14 and 14 times 3, just to make sure, 42. So negative 42. My s's are gone. I get negative 10f. I get minus h. And 42 minus the 24 is going to give me negative 18 left over. Okay, so there's my second equation that I'm going to have. Now, what do I need to do with these two? I need to stack those up. All right, so I'll do that here. Negative 10f minus h equals negative 18, and negative 5f minus 3h is equal to negative 1650. So that's my new 2x2 system of equations. So when I look at this, that's a 10. I'm going to multiply, let's see, I'll multiply the top row by a negative 3. The reason I'm going to do that is I like to add my equations together. So if I times the top row by negative 3, that'll make that a positive 3h, and that'll cross out with that. So if I times by negative 3 on top, watch how I kind of do this, and you'll learn as you get better with systems. Negative 3 will give me a 30f, negative 3 will give me a positive 3h, and then 18 and 3 is going to give me 54, positive 54. So I kind of scribble that one out because I'm all done with it. Now I'm going to add those two together. Those cross out, and this gives me, let's see, 25f equaling 54 minus 1650. Minus 1650 is going to give me 3750. And then I'm going to divide that by 25. So I'm going to divide that by 25. That gives me $1.50. So what did I just figure out? I figured out that fries cost $1.50. Okay? And then we want to go back and plug that back into any of our equations that I had for the 2x2. So I'm going to plug that in for right here. So I'm going to have negative 10 times 150 minus h equals 18, negative 18. So I'm going to have negative 10, so 10, that's going to give me 15. So let's see, it's going to give me a negative 15 minus h equals a negative 18. I'm going to add 15 to both sides. Negative h is going to equal negative 3. And so if I divide by negative 1, I'm going to get a positive 3. So now I have a hamburger's $3. And then I can go back to any of the original equations, which are off here to the left, and I'm going to plug it in just to equation 1, just for kicks and giggles. You could go 2 or 3, but I'm going to go 2 instead of f. That's now $1.50 plus 5h. H is now a 3, and I want to solve for my sodas, so that stays as 3s, and that equals $24. So 2 times 150 is $3. 5 and 3 is 15. That's 18 plus the 3s equals 24. I'm going to subtract 18 from both sides. I get 3s is equal to 6, and so sodas must be 2. And so now I have found my sodas are $2, hamburgers are 3, and my fries are $1.50. So that is how you do systems of 3 equations and 3 unknowns. It's all about this. Eliminate the same variable twice. If you can eliminate the same variable twice, you get a nice 2x2, and you should know how to solve a 2x2 by now. And if you have questions, I'll see you in class.